This lens costs $200,000. It can see objects that are kilometers away. You are looking at one of the most expensive camera setups in the world. Have you ever wondered why TV production companies still use very big and expensive cameras? I mean, come on, why can't they just use DSLRs with zoom lenses that can shoot 4K in high quality, they're not expensive, they're lightweight? Well, actually, there are a few reasons why we can't really use these type of cameras in a broadcast environment, and this is exactly what we're going to see today. When you see that big beefy setup that weighs 152 pounds at a retail cost of $250,000, you have to know that the camera itself is actually quite small, because most of the cost and weight come from the accessories that surround it. The first one being the lens, which can be much bigger than the camera itself, and in the setup you're seeing, the lens costs 70 times more than the camera. The main concern about shooting a live performance is that you don't always have that much choice over camera placements. In a football match or a concert, for instance, you can't really put your camera right in front of the player for your medium shot, right? Therefore, it's rather common to have cameras far away from the action. So you need a lens that has a long focal length to reach far away. In addition to this, operators often need to zoom in and out quickly, so you do need to have a very big focal range as well, without having to switch to another lens right in the middle of the action. Oh, and when you zoom in and out, the last thing you want is losing your focus all the time, so the lens has to be parfocal, which means that it will always keep the subject in focus when you zoom all the way in and out. Also, when you are doing a tight shot, you can't really touch the lens directly to change your focus, because at a long focal length, the slightest tap would strongly affect image stability. Thus, the lens needs to have remote control motorized aperture, zoom and focus controls. The zoom mechanism has to support extremely fast zooms to check focus, as well as very slow movement for subtle emotional moments. Finally, there are many situations where lighting conditions aren't ideal, so the lens has to have a big aperture. In a nutshell, a broadcast lens must have a long focal length, variable zoom with a big focal range, a big aperture, parfocal capability, image stabilization, and motorized controls with high precision. You can find plenty of photo or even cine lenses that offer a few of these features, but none of them offer all of the features at once in one single lens, and because it's very hard to make. For instance, the UA107 box lens from Fujinon can zoom from 8.6mm to a whopping 1800mm with its built-in extender, with a maximum f-stop of f1.7, which is pretty nice. Now, most broadcast cameras use 2/3 inch sensors, which I think have a crop factor of 3.93, so the full frame equivalent lens would be a 33 to 7020mm, which is huge. Now, with a simple formula, we can see that at 900mm focal length, a max aperture of f4.5 will give us a required optical diameter of 200mm, which is why the box is so big. Add in all the electronics, the motorized servos, the extremely high quality glass elements, the housing, and yes, you end up with a very big and expensive lens. When you add up the camera, the lens and the accessories, the total weight can quickly build up, reaching over 100 pounds. So you do need a very heavy tripod to support that weight. Also, you want your total setup to be very sturdy, since you definitely don't want to see that camera setup tip over and crash. So the tripod base has to be very solid. Besides, the build quality of the fluid head on top is very important, since it has to dampen and absorb every small vibration or accidental jerk from the operator, especially when you are zoomed in all the way. The more you zoom in, the more an external tap will have an impact on the image stability. And in extremely tight shots, a jitter can actually be triggered by just a heartbeat. More weight means more stability overall, so this is why tripods used in broadcast are so bulky overall. Finally, operators need to be able to adjust the dampening and braking level very precisely, depending on the type of shot. So all of this technology does come at a cost. Another important feature of a broadcast camera is its monitor. Since the camera operator is also the focus puller, the small camera monitor is definitely not enough. He has to have a clear view of the image on a big and accurate screen that can easily be tilted. This type of screen also has quick access controls to set settings like focus peaking, contrast and saturation, for instance. There is also an LED indicator that is called the tally that turns green when the director is about to take the shot and red when the current shot is actually on air, which tells the operator to be very careful. As I mentioned earlier, it's very important not to touch the lens to adjust focus, zoom or aperture. Therefore, the lens needs to be operated by highly precise aperture, zoom and focus motors that are controlled by remote handles. For convenience, these remotes are attached to the two tripod handles for permanent access throughout the shoot. These are called zoom and focus demand and are pretty much the broadcast equivalent of the wireless follow focus systems used in the cinema industry. Finally, I didn't mention the camera itself, which is pretty small in comparison to the rest of the setup, but it is still bigger than a DSLR or a consumer camera. So again, is this really necessary? Well, these kind of cameras do have features that are not present on consumer cameras, such as multiple buttons for quick access to settings instead of having to dive through the menus, internal ND filters which allow you to have better control over exposure outdoors. It has an internal camera control unit, or CCU, which empowers a remote operator to do live color corrections directly into the camera, as well as a special fiber optic transmission module so that all of the image signal and power travels into the same rugged cable for convenience. Implementing all of these features does take up some space, of course, and it's actually a good thing because in that way you can use the camera on its own on your shoulder with good stability. So this is another feature that these cameras have. So, loads of things have been said here, but it all comes down to one thing that you have to remember. In traditional video, it's the environment that adapts to the camera, which means that you can redo takes, you can switch lenses, you can move the camera wherever you want. In broadcast, it's the opposite. It's really the camera that has to adapt to the environment all the times. So you have just one shot and you really need to maximize efficiency to capture as much action as possible. So it's this one-size-fits-all approach which makes these broadcast cameras very big and expensive. This huge box lens setup isn't the only broadcast configuration available. You can also use the camera on its own with much shorter range lenses. Of course, they also make lenses that have a price tag much closer to this 3000 Ursa broadcast from Blackmagic Design. It's a camera that I personally have and I use on a regular basis. I want you to know that I was not paid by any brand to make this video. It's really out of my personal initiative, but I did ask Blackmagic Design to lend me most of the gear that you can see at the back there. So I would really like to thank them for accepting my request and making this video possible. Also, I did pay for for a complete rental of the lens and tripod at a company called Video Plus France. So this video overall wasn't very cheap to make. I really hoped you liked it, and if I said something inaccurate, please correct me in the comments. I'd be really happy to read you to just have your thoughts on the video anyways. So in any case, thank you very much for watching and see you very soon.